So we were into this radian business, right, in the last session. So can someone tell what is meant by radian?
The angle created by the in the center of the circle where by the arc equal to the value of the radius.
Yes. So what question I told you yesterday that if anybody teaches you anything new, what question you should ask?
Why do you learn it?
Why do you? So now you tell me, why do you learn this?
To find the value of
Why do you learn this? To make programs?
to do the next level things.
But you didn't ask me that yesterday, right?
Yes, sir.
Yeah. So you spared me yesterday without asking this. So that's why I was telling you, whenever somebody teaches you something new, you should ask them. See, first you tell us why we should learn this. What is its utility? Yeah? Right? Agree? Yeah, 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 yeah. Okay. So we told now, first I just told what does it mean. That's the only thing what I told yesterday. So we made this diagram and we told one radian is the angle made by an arc length of one radius. We told about this example, right? And we calculated the value of it. Is it not? We calculate it is 360 by 2 pi. Why 360 by 2 pi? Because the whole circumference is 2 pi r. So like what Shivananda told yesterday, like this, 2 pi arcs are there, like this, 2 pi arcs. That is why the circumference is 2 pi r. Yeah. So that means a whole circle 360 degree is equal to 2 pi radians or 6.28 radians. That is how we get the value of 1 radian as 57 point. Yeah. So how many radian is 180 degree?
So you like
How much?
Pi.
Pi. 2 pi is 360. Is 180 is pi, no? Yeah. Right? 90?
Half pi.
Pi by 2. Yeah. So that is the notation which you will normally use, especially when you do in trigonometry and all, for telling sine 90, sine 60 and all those things. This is the notation you will use. You will use it in radians. There are reasons for that. Okay. So, you know, 360 is 2 pi, 180 is pi, 90 is pi by 2, 60 is pi by 3, 180 by 3, right? 45 is 90 by 2, so pi by 4. 30 is 180 by 6 or pi by 6. Get it? So if you put it pictorially, it will look like this. This is 0, right? 180 is pi, 90 is pi by 2, 270 is 3 pi by 2. See, it is coming this side, 270 degree. 30 is pi by 6. So this is how, if we divide the whole circle, normally we use up to 90, up to 180 very frequently. Yeah. So if you tomorrow somewhere when you learn further things, if you tell sine pi by 6 means sine 30 degree. That's what it means. Okay. So now let us see why do we learn this? One utility, one application. Okay. What is the reason? Okay. So that is another toughy maths. What is the question? How many radians angle and arc length of x would make? So these words can be confusing, right? When you read this, sometimes it will take 1 minute for you to make sense of it. because there are too many puzzles: arc length, radian, angle. See, so when you get into problems like this, you should first draw it. When you draw it, you will get an idea. See, what are we asking? How many radians angle an arc length of x should make? An arc length, any arc length of x. If this is x, what is this angle? Normally in degree you can't find it out, right? If you tell some circle, how much angle in degree one arc of x centimeter will make? Yeah. So in degree you can find it out, but not in a straight way. But in radians, you get a very easy expression which is very widely used. Find it out. This is straightforward of maths. What is this angle in radians? If this is x centimeter, what is this angle in radians?
So we have to divide it by 360, right?
Divide what with 360, Adnan?
X over 360.
Okay, so x over 360. So what do you get that? X by 360 is what? X by 360 is the ratio of
X equal to 360 by 2 pi.
Okay. S
So
360 by 2 pi is 1 radian, right?
yes.
Yeah. X is that? X is 1 radian.
Yes.
How you know? You don't know the length. Whether this is 1 radian is if this is equal to 1 radius, then this is 1 radian. You don't know this is whether the x is equal to r. X is unknown.
X by R.
Wow. Explain.
If R is 1 radian and
Yes.
1 centimeter will be 1 by R. So x centimeter, x by R.
What principle did you apply?
Toffee math.
That's it. See, there is no rocket science. Did you understand? See,
I
Shivadanda get that toughy maths. There is no rocket science. This problem is same as you are telling r centimeter makes 1 radian. 8 toffee costs 40 rupee. How much does 3 toffee cost? This is same problem. This is 8 toffee. This is 40 rupees. This x is 3 toffee. So it's all depending on can you place the problem into toffee maths terms. But if you get frightened by seeing angle, number, this, x, r and all, it will go for a toss. Can you all try again from what Shivadanda told, explained? R centimeter makes 1 radian. How much radian will x centimeter make? If r makes 1, how much will x make? It boils down to that. What do we do? Mandana, what do we do? R centimeter makes 1 radian. We want to see how much x centimeter will make. What do we do?
Unit value.
We do unit value. That is 1 centimeter. Right? We will try to see 1 centimeter will make how much angle, how much radian. What is that? If r centimeter makes 1 radian, how much will 1 centimeter make?
1 by R.
1 by r, this is just division, right? 5. See, that's what I'm telling. The fundamentals of toffee maths, don't lose it when the numbers become different. If R centimeter, if 5 toffee, if 8 toffee costs 40 rupee, 1 toffee is 40 by 8. This you just divide any time. Sounding principle of maths. You want to find unit value, divide with that value. For which value you want to find unit value, just divide with that. 360 degree is equal to a circumference of 2 pi r. How much length for 1 degree? 2 pi r by 360. Whichever stuff you want to see for one unit value, that value you divide with that, you get the unit value. It is universal principle. You know it actually. If it is 8 toffee and 40 rupee, how much is 1 toffee? You tell by heart. But when the number changes, you get confused. Can I divide by 1? Will the police come and charge a FIR against me if I divide by 1? You get into all those kind of unnecessary complex doubts. So don't think straightforward. If r centimeter makes 1 radian, 1 centimeter makes 1 by r, just divide with this. Don't bother what is the value here, what is the value here. This could be some e raised to x and this could be sine theta square. You don't bother. It is maths headache, yeah. Why are you bothered? Yeah, just follow the principle. Now, what is the question? How much will x centimeter make? You got unit value.
X by r.
Now that is 1 by r into x. 1 by r into x by r. You see, this is a beautiful expression. You want to see the angle made by any length of any circle, you can just divide that length by radius. You get that value in radians. This is widely used in so many problems, so many applications. You see, it's so simple an equation, right? Somebody tells, okay, I have a circle. How much angle 30 centimeter will make? 30 centimeter by r radius. Just whatever is this arc length by radius. But the value is in radians, okay? Do you get this?
I see.
Yeah, you don't know where is it coming from. So this is where it is coming from. So I have used this in and out when we are studying engineering, but I was never knowing how this has come from. Okay, so so it is important that you know where it is coming from. So that is x by r. Okay, the next one. So the next problem: what is the speed of rotation of Earth? You want an input? Anyone wants an input?
Sir, 460 meters per second.
Yeah, how did you get it? Google will tell the answer, that I know. I'm not asking how good you are in searching in Google. That's not our topic.
How much distance it rotate in 24
hours? Very good. In 24 hours, how much distance the Earth rotates? That's a good beginning. Yeah. How much distance? How do you calculate that?
equator?
Equator.
The distance from one point to till then.
One point to another. Okay, I give you that. Okay, you ask what I have. Equator from one point to another, which is what we call as diameter. Right? This is the diameter. Is this what Earth covers in 24 hours? This is the diameter of Earth in equator. Of course, the speed will slightly change in polar region. Don't bother about that. We are not trying to learn geography here. So take the equatorial plane. So here, if you want to see what is the speed of rotation in equator, how much distance does Earth cover in 24 hours? Is it this?
No.
Hmm.
I told if we are standing in the topic of Capricorn, the point till then we cover the Earth. Backwards we come and.
Yes, you assume you are in equator. How much distance you will travel in 24 hours? If this is the diameter?
2 pi.
2 pi.
2 pi d.
2 pi d or pi d?
Pi d. No,
Pi
r.
d.
Pi d.
Yeah. Pi into d. Adnan's pi. Right?
I see.
Yeah. It was like the life of pi. It is Adnan's pi now. Okay. Adnan's hatred towards pi we want to reduce by each class. So that after going while leaving this course, Adnan, we want him to hear I love pi now. Yeah.
Hopefully.
Yeah. Okay. So all of you understand this? If this is the diameter of Earth in the equator, in 24 hours, actually you round the whole Earth, right? That means one circumference of the Earth is what you cover in 24 hours, right? So from this diameter, you have to calculate the circumference. It's very simple, right?
Yes, sir.
Yeah.
12,756 divided by 24.
That is not right. 12,756 by 24 is the speed if you are starting from one point in the equator to the other point in the equator. If you walk in 24 hours, what is your speed? That is 12,756 by 24. That is not what we are
So
doing.
that is through the Earth, right?
Yeah, you see, yeah, it is the circumference what matters. You are not walking through the center of the earth, right?
Yes, the circumference. Yes.
The circumference, Vinayak. This is there. Right? Visualize it. You are rotating, right? This is the dia. So
It could be
Avinash,
rotating. It could be rotating from the right to the left.
yeah, whichever way the direction of rotation is immaterial here, you know that, like Avinash told, in one day you complete one rotation. That means in 24 hours you complete one rotation. So don't bother about the accurate value, only bring the expression. Accurate value calculator is there to give that. So I am not checking how well you are with calculator or Excel, okay?
2 pi d by 24.
Repeat.
2 pi d by 24.
Yeah, 2 pi, what is d here?
12,750.
Diameter.
Avinash, it is pi d, it is not 2 pi d, it is 2 pi r. Circumference is pi into d. Pi is
Okay,
the,
sir.
you only told yesterday, pi is the ratio between circumference and diameter. Now you are telling 2 pi is, we are taking.
Because I heard the equation 2 pi r.
Yeah. Instead of d, if somebody is giving you r, 2r is d. Right? Equation is pi d. Circumference is pi d. Now, if you don't have d, if somebody gives you r, you have to calculate d from r. That is 2r is d. So this is straightforward toffee maths. In 24 hours, you travel this circumference. Right? Pi into this one is the distance you travel. In 24 hours, you travel this. So in 1 hour, how much you will travel? Yep. Right?
Yes, sir.
See, this is 24 hours is 24 into 60 into 60, that means second. This much in this much time you travel this much distance. So in 1 hour, how do you find out? That is same thing. 8 toffee, 40 rupees, 1 toffee, how much? Right? This divided by this. Straightforward. Move on. Assignment for you. Further assignment for you. So that if you are eagerly waiting to do assignments, you can do these things. Find out simple toffee maths, nothing. You just browse and get the
So,
diameter.
but revolution, how we could get the diameter?
Yeah, just browse in Google. Everything else you get through Google, right? You whether Britney Spears' new song has come, and now Deepika Padukone, whom she's dating now, you get all those information from Google. So this also you can get, Avinash.
What?
No,
What you say?
No, my point is you get all the information about who dates whom, who has crushed with whom, all those from Google, right? So this also you can get from Google. Some useful things also you can try, right?
I
And
see.
then, yeah. So all in a sudden, these kind of things you should not get doubt of where from you will get now. What is the diameter of Earth revolution? Right? Many other
Sir,
things.
you told the Earth's orbit is elliptical. So how will you get that doubt?
Yeah, that's what I'm telling. See, we are not trying to learn geography here, so that approximation is okay, Avinash. See, I mean, we are trying to see the maths of it. So the geographical complexity we are not bringing into picture here. Yeah, this is for you to understand the maths of it. Okay, okay, right. Moving on to your next problem. So from geography we move to chemistry. So Avinash, you don't have to Google this. I am giving you this information. So I was sure you would ask where from I'll get this now. Okay. So I've already given you one carbon 12 atom weighs 2 into 10 raised to minus 23 gram. Yeah. You're also asking other day, right? Sir, why do you want to learn 2.57, 3 decimals and also? This is how.
What does it say? One carbon 12 atom. Is it
What?
one carbon? Like
Car-
one carbon. There should be a comma in between, right? One carbon, comma 12 atom. One carbon 12 atom.
Carbon 12 is the name of one of the isotope of carbon. Yeah, carbon has many isotopes. So carbon 12 is the name. Carbon 12 is a name, like your name is Adnan Shershi. What's that? Shershij, right?
Shershij.
Yeah. Like that, carbon 12 is the name of one type of carbon isotope. There can be carbon 30, there can be some other carbons also. Okay, so that is the name. So what does it mean? That means that specific carbon has 6 is its atomic number, not atomic number. 6. You can take it like 6 protons, 6 electrons, 6 neutrons are there in that. That specific stuff. There are some other forms which has some other structure. So carbon 12 is the name of that. So assume it is the name of that specific stuff in the periodic table. So one atom of that weighs 2 into 10 raised to minus 23 gram. One atom. Okay. So the question is, how many atoms are there in 12 gram of carbon 12?
12 into the equation they give there.
There is too quick an answer. So you sacrifice accuracy for speed.
12 divided by the weight of one carbon atom.
Is that hyphen a negative or is that just a hyphen?
That's negative.
Okay.
Adnan,
Yes.
you just think, can this be positive?
No, the one in front of 2.
Oh, no, this is not negative. How can mass be negative? Mass cannot be negative, right? This is approximate. This symbol means approximate. Approximate.
I see.
This mass can never be negative, right? Well, it can be negative, but in your understanding, for your classes, it cannot be negative, right?
So the unit value is given, so just divide by the number. The second topic max you teach.
Yeah. Divide what with what, Avinash?
The weight by the weight of one carbon atom. Total weight 12 gram by 2 into 10 raised to 23.
Oh, 12 gram by 2 into 10
2
raised to
into
23.
10 raised to minus.
Yeah. How you got it?
Because the one carbon atom weighs this. So if you want to find one carbon atom weighs 2 into 10 raised to 20 minus 23. So if you want to find the number of atoms in 12 gram, you could just find how much is this.
Okay.
Just place it in like a circle you can know how much will the atom will come in 12 gram.
Yeah, so that means
So you can just divide.
yeah, you are right. So in second of him, like in 12 gram, how many 2 into 10 raised to minus 23s are there? Right? You are right. That is the second of in maths. A school has 600 students, right? One class has 20 students. So how many classes are there? So in 600, how many 20s are there? So like that. You are telling one atom weighs 2 into 10 raised to minus 23. Now you are asking 12 gram, how many are there? So you want to see in 12 gram, how many these pieces are there? So 12 by this. That's a good method. I am happy that at least you are getting it right. Yeah. Anyone else? The first method you want to apply? Unit value? Unit value you want to apply? See, what is that you want to see? 12 grams value you want. So if you get for 1 gram, you can find for 12 gram, right?
Yes, sir.
Yeah. So 2 into 10 raised to minus 23 gram equivalents 1 atom. Right? So 1 gram means 1 divided by 2 into 10 raised to 23, right? Reverse, you look at it. 2 into 10 raised to minus 23 gram is equal to 1 atom. So 1 gram means how many atom? Such of telling whatever you want to see unit value, you divide, that goes to the denominator. Here you see, before it was like 8 toffee cost 40 rupees, 1 toffee. So you want to see 1 unit value of the toffee. So the value of toffee 8 will go to denominator. So that is standing principle. Here you want to see 1 gram, unit value of the gram. So that will go to denominator. That is the fundamental principle. So 1 gram is this much. So how much is 12 gram? 12 gram is this into 12. 1 by 2 raised to 2 into 10 raised to 23 into 12. Or the other method what Avinash said is also very good. That is the second topic. This is first topic math. This is second topic math. He is telling in 12 gram how many these pieces are there. This is also gram. This is also gram. So that means you know so many 2 into 10 raised to minus 23. So many atoms are there in 12 gram. How many are there? Divide this with this. That is same thing. 12 by this. This division actually you can do straight up, right? 12 by 2 is 6. 10 raised to minus 3, when it comes to the top, it will become 10 raised to plus 23. Right? 12 by 2 is 6. 10 raised to minus 23 from denominator. When it comes to numerator, this minus will become plus. Yeah?
So no exact value.
Come again?
We have to, we cannot like, make it, we cannot do further things like, 6 into, do the equation first, 10 to the power of 23, and then multiply that by 6.
Yeah, you can do whichever way. I'm telling you, we are bothered about how to get the expression. This is one expression you can write it in whichever way you can write. This is 16 into 10 raised to 22 or 0.6 into 10 raised to 24, whichever way.
No, but like sometimes we will get like unfinished and we get half marks because we didn't do the full thing.
Yeah. Yeah, I feel sorry for you guys. Actually, it's a very unfair thing for a teacher to do. Like, see, the exam is something to check whether the student knows something. Once we know the student knows it, we should give full marks, right? So that is
In
important.
chemistry, we should write in this way, or we will cut the marks. Chemistry for atoms and molecules. For other numbers, we should write in the.
Okay. I think if any teacher cuts mark for writing like this, I think we should do something. It's a very reasonable way of writing. Okay. Yeah. This number, have you seen?
Yes, I have seen these numbers.
Where? In a shop or some supermarket?
No, I write them down, I look at them.
Yeah, but is this number familiar?
Avogadro number.
Yeah. Have you heard of Avogadro
That is
number?
6 point something. 6.0.
6.22. It's same, not a very small change, very minor. 6.022. Right? What is Avogadro number?
The number of atoms in 1 mole.
Okay. What is 1 mole?
That number of 6.022 into 10 raised to 3 by the mass.
That you're telling the reverse of it. What is 1 by 1 mole?
6.022 into 10 raised to 23.
Okay, then what is Avogadro number?
That's same, right?
Then I will take the Pashupadastra now. Why did you learn mole in this?
It's a chemist counting unit for
Good
counting.
point. Very good, very good, very good, very good. Mole is a good counting unit. Yeah. Why? What problem it solves?
It is hard to express a number in such a small number in this form.
Very
So we
good. Very good. Excellent. Yeah. It is very difficult. Like if you want to do an experiment, for example, H2O plus magnesium sulfate, you want to say 2 portions of magnesium sulfate and 1 portion of H2O. You want to take it like that. While recipe, when you do cooking, they will tell take this much of dal, with that add this much milli of water, in that you put this much of dhania. No, there is always quantity. So when that quantity comes correct, only that recipe works well, right? So for any chemistry experiment also you want to do that. So now if you take 1 portion of H2O or 1 portion of magnesium dioxide or aluminum stuff, you know how many atoms are there? You can't count it. It's very difficult, right? You can't take atoms and count 1 H2O, 2 H2O, 3 H2O, right? Yeah. So what do you want to do? You want to take large number of atoms and call it with one name. Yeah. So this Avogadro number is one such stuff. Now 1 mole means what?
I've never learned about this
Same.
Avogadro's number, so I don't know what y'all are talking about.
Which class you are at then?
I'm grade 9. Which class are we supposed to learn this? Because I switched syllabus
This
to
year
syllabus.
study. This year you will study.
Yeah, I don't know
I
which
see.
class they teach you, but you learn it now. At then.
I see.
It's a very, very important concept in chemistry. You learn it now. So now, so this is the problem. If you want to do chemical experiments, lab and all those things, you want to see how much quantity. So if somebody tells you take manganese this much and 2 times of that you take oxygen. If somebody tells like that, how do you know? So you create a quantity where you see that quantity is called mole, and you know 1 mole of oxygen, how many atoms are there in that is equal to number of atoms in 1 mole of manganese, is equal to the number of atoms in 1 mole of aluminium, is equal to the number of molecules in 1 mole of H2O, is equal to the number of molecules in 1 mole of carbon dioxide. So 1 mole of that means any molecule means this many number of atoms or molecule or proton, whatever you take that 1 mole, this many number will be there in that. So you can tell the recipe is you want to take 1 portion of manganese and 2 portion of oxygen. Then you can tell 1 mole of manganese and 2 mole of oxygen. Automatically 1 mole of manganese will have this many atoms, 2 mole will have this into 2. So that proportion gets right. That is a utility. Yeah, that is a utility. Now, how this magic happens? How can 1 mole of H2O has same number of molecules as 1
Its
mole
mass.
of... Yeah.
Its mass.
So what is 1 mole? That is where the importance comes.
Its
mole,
mass in grams.
Yeah.
Yeah.
Its mass in gram equal to the number of What gives mass to an atom?
Number of
Protons and neutrons.
neutron,
Navjit, number of?
Proton and hydrogen.
proton and neutron.
Number of protons and neutrons, right? That is the chicken and mutton in atom. This electron is...
Now I understand.
Yeah, see? Now you see this electron does not give much. It is like popcorn. You eat. Just you eat for time pass, you know. Doesn't add much flesh and all those things, you know. If you want flesh, you know, proton, neutron stuff, atom is like mutton, chicken, your milk, curd stuff is what proton, neutron and all. These electrons and all this chotu motu, agadam kagadam stuff does not add much weight, muscle. Yeah? So like Navajit told, the weight mass is given mostly by proton and neutron. So for all the practical purpose, you take proton and neutron. So to tell the mass of an atom, we use this method. We just count how many protons are there, how many neutrons are there, add these and tell. We call both are mass of proton and neutron are almost the same. Almost the same. Both have 3 quarks. I hope you remember particle zoo. Our friend Rohin had taught you. Both have 3 quarks. Only which quark come in which is the only difference. So proton is also 3 quarks. Neutron is also 3 quark. Electron is just like quark, another particle. Okay, so that mass is very negligible. So we call the mass of one proton or one neutron as one. There is a unit for that. There's a unit.
Atom A in the U.
Atom.
Yeah.
Atomic mass unit.
Yes,
AMU.
yes, AMU. Yeah. So AMU, right? So now you tell me. One helium atom. What will be the mass of helium atom in AMU?
2U.
4U.
Yeah. 2 proton and 2 neutron. Right? Proton and neutron has almost similar mass. So it is 4 AMU. What is the mass of one hydrogen atom?
2U. No, 1U. Sometimes 2U.
2U.
Isotope.
Yeah, because normal hydrogen doesn't have neutron inside. You remember I taught you during Big Bang,
Yes.
the first thing to be formed was
Yes.
1 proton, 3 quarks hit and form the one proton. So that is what is called H plus. Then after so much time, the electrons, the next era, the next force comes into picture, electromagnetic force that comes and binds 1 electron to this, which is what we call as normal hydrogen atom. That is why hydrogen is abundant in this universe. You remember? Yeah?
Yes, sir.
Yeah, so this chemistry, physics, math, all are same. You should understand. Okay. So this, now you tell me what is the mass in AMU of 1 carbon atom? Carbon 12, normal carbon.
12U.
12 AMU, right? Okay, 12 AMU. That means what? In a typical carbon atom, you have a mass of 12 because 6 proton and 6 neutron. Now is the trick. Now is the trick. You see, you know the mass of proton and neutron is almost same. So you can calculate in 1 gram. In 1 gram, how many protons or neutrons are needed to weigh 1 gram? That will be constant. So in 1 gram proton, how many protons are there? Will be same as in 1 gram neutron, how many neutrons are there? Right?
Yes,
Is
sir.
it? Yeah. And And that will be same as in 12 gram carbon, how many carbons will be there? Will be same. Because one carbon atom is 12 AMU or 6 proton plus 6 neutron. Right? So in 1 gram, how many protons are there? 1 gram, let us assume X number of protons are there in 1 gram. Then in 12 gram, the number of carbons will be the same because one carbon atom is 12 AU. So that is what is called mole. So mole means what is the AMU value? AMU is the mass of any atom, that much gram. So carbon 12's mass is 12 AMU. So 1 mole of carbon 12 is 12 gram. Same AMU, you can make it as gram. So for hydrogen, one hydrogen atom is, if it is normal hydrogen, is 1 AMU, means 1 gram of hydrogen is 1 mole. If H2O, if it is 18, is its total, if you add all the atoms, if total 18 AMU, 18 gram of H2O is 1 mole. So why you keep that? Because the number of atoms in that quantity will be the same as this value. So 1 gram means what? 1 gram of proton will contain this many protons. 1 gram of neutron will contain this many neutrons. So Avogadro number you will get if you just calculate this. Go home and calculate this. How many protons are needed to weigh 1 gram? Or how many neutrons are needed to weigh 1 gram? You will get the same number. Does that make sense to you?
Yes, sir.
I see.
Adnan, do you get that now?
I see.
Others, do you get this?
Yes, sir.
Yeah, so I don't want to make this a chemistry class, but understand the fundamentals. Yeah? Then this is nothing to do with the Mallu name called Sneha mole, Srija mole and all of those things. That mole has nothing to do with Avogadro number, okay? That is mole is a different business, okay? This mole, 1 mole of any atom or molecule is how many AMs are there, that many grams. And that is made to ensure that in that equal number of these things. There is no magic in that. It is because of this. So go and do this, you will get this. Actually, it is simple toffee maths, all those things. The only thing when number becomes complex, you will get frightened. Oof, 10 raised to minus 23, you will get frightened. There's no need to get frightened. So just see this 2 into 10 raised to minus 23, you consider it is x. Just consider it is x and replace. Don't get frightened by seeing the large value. Okay, now from chemistry, now we get into biology. Okay. So now this ant, this third ant, tells there are 2 ants coming behind me. And this ant tells there is 1 ant coming behind me. And this ant tells there are 2 ants coming behind me. How can that be true? This is a very famous riddle. Haven't you
Let me
heard
just
this?
search it up.
This is one of the many ant riddles. Haven't you heard this?
Sir, they were moving in a circle.
Okay.
No, like the last ant, his mind is not working well. Because there's no possible way that it's clearly all like this.
So in our school days, the answer we used to tell is that this ant was lying. Okay. So now then it came to such a pause that if anybody starts talking about this ant job, people will come round up and will start hitting you.
So there's no answer.
The answer is this ant was lying. This is not a decent answer. Okay. Okay, so
That's why people
now,
say keep it simple.
yeah. So like you are also right, this ant is having some trouble. Okay, yeah. Okay, anyway, coming to jokes apart, you see now, assume that the ants are traveling at a speed of 10 meter per minute. Okay, they're traveling at a speed of 10 meter per minute. Now, I have got this picture. In this, there are gaps between ants, but assume that these ants are traveling straight. Now, this is serious. Okay? This is no puzzle. Okay, these ants are traveling straight and behind one behind another, like straight line. Now, the length of one ant is 1 centimeter. That means one ant's length is 1 centimeter. Speed of ant is 10 meter per minute. How many ants passed in 1 minute? Tough maths. Passed in 1 minute means, let us assume you are standing here. These ants are moving in a line at a speed of 10 meter per minute. From here, you are standing here and you are counting. Your clock starts. In 60 seconds, 1 minute, how many ants would have crossed? There is no trick here. Okay, this is not a puzzle or riddle. This is
1,000. 1,000.
1,000. How did you get it?
Well, because 1 meter or 1 centimeter, 10 meter is equal to like 1,000 centimeter.
Wow, very good. I'm very happy for you. That worked pretty fast for admin. Superb. You want to explain to others?
It's pretty obvious.
Is it obvious for others? Let me ask.
No, sir.
Yeah, no, it's not that obvious. It is a bit tricky actually. Somehow you got it. That means you are picking the toffee maths very well. Yeah.
No, like 100. Wait, 1 meter is like 100 centimeter, right? So 10 meter is
Yeah, yeah, he's right.
100 into 10.
Actually, he got the picture right. You see now, assume these are our ants who are going straight. Okay. Now let us mark an ant starts from here. After 1 minute, that ant will reach here. Then after 1 minute, ant will reach the next point. Now you see, if an ant is starting from here, now you start from here you are measuring. You have a clock, stopwatch. You start. After 1 minute, the first ant reached here. So what is this distance?
10.
10 meter.
10 meter.
So that is what the speed means. Speed means in 1 minute, how much distance you travel. So what if you are sitting here and measuring, this ant will reach here, next ant will reach here, next ant will reach here, which means in 1 minute, this ant will reach 10 meter, and in the next minute, it will reach 10 more meter, right? So now if you want to know how many ants pass in 1 minute, first ant is here. So when you started measuring from here, 0 second, this ant crossed. 60th second is at this point. So how many ants are there between this point and this point is equal to the number of ants passed in 1 minute, right? Is it not? You are standing here and watching. This first ant was here. Now, first second, we started walking, second, third, second, fourth. 60th second when you clicked, let us assume 60th second you are seeing these many ants have crossed. The first ant is here. So, how many ants are between the 0 and 1 is equal to the number of ants passed in 1 minute, right? Or if you are measuring here, in here, how many ants are there? Is it not?
Yes, sir.
So then now it becomes toffee maths. So somehow Adnan caught this visualization, he caught it fast. It is not very easy to get it. He caught this once you get this visualization, then the things are easy. In 10 minutes.
I did with the numbers. Yeah.
So the thing is in 10 meter, now the question is in 10 meter, how many 1 centimeters are there? Right?
Yes, sir.
Yeah. So nowadays the things become simple. Number of ants passed in 1 minute is in 10 meter. How many 1 centimeters are there? Now 10 meter is 1 meter is 100 centimeter is 10 into 1000. So you get 1000. Everyone gets this. Others. So do you think I told this for ant business? No. I have vested interest in this. Okay. Now replace ant with wave. Replace ant with waves. Just assume one wave is one ant. Okay, same problem. Speed of light is 3 into 10 raised to 8 meter per second. Speed of ant was 10 meter. 10 meter, 1 meter, what I told, 10 meter per minute, right? Yeah. So speed of ant was 10 meter per minute. Here speed of light is 3 into 10 raised to 8 meter per second. Assume this is light wave. Wavelength, length of ant. Instead of ant, here it is wave. What is wavelength? Length of wave, right?
Yes, sir.
Yeah. So as red length, red light, it can vary. Approximately, you consider it is 700 nanometer. 1 nanometer is 1 into 10 raised to minus 9. Okay. 1 nanometer is 1 meter divided by 1 after that 9 zeros. That is 1 nanometer. It's very small. So now you got the length of one wave. Yeah, this is wavelength. You can measure like this or like this. Length of one wave. Same problem like ant. Ants are moving. One ant is previously 1 centimeter. Here it is 700. Speed of ant, speed of light. Tell how many waves will pass in 1 second. Same problem. Do it. You don't have to find out the calculated expression. If you have calculator, you can go out. Tell the expression. Same problem, toughy maths. Same and business. Just think how you did the ant problem. Do in the same manner.
700 into 3 into 10 raised to 8.
700.
Shifted
That
into
that means
nanometer.
the point. That would mean the point will go to the left, right? Because
Make a diagram. Mark. And then find. Don't do this in mind, okay? Don't try to do complex problems in mind. Don't think it is smartness. It is foolishness. Complex problems, don't try to do in mind. You can do that for improving mental power, but for exams and all, don't do that. Write and do. Let that 1 second extra and that much ink from your pen go.
700 nanometer into 10 raised to minus 9 into 3 into 10 raised to 8.
Okay, I hear you. Try to make the same diagram we made for the ant.
no, sir, the nm is nanometer. Nano.
Yeah, forget about it is
Nanometer.
nanometer. You don't bother it is nanometer, it's a small number. You just put that figure 700 nanometer. You get the expression, value we will calculate later. Just get the method right. Okay, we go back to ant business. Okay, speed of ant is 10 meter per minute. Length of ant is 1 centimeter. We are asking how many ants pass in 1 minute. What did we do? We try to see from where we are measuring. So from where here we are measuring. Okay. What we told in 1 minute, it travels 10 meter. So we see in 1 minute where it goes. In 1 minute, I started from here, 1 minute it reached here. So what does that mean? This distance is 10 meter because that is my speed. So now I know when I started counting from here, the first ant reached here, in 1 minute, this many ants have crossed this point. Between this and this, how many ants are there? That many ants have crossed this point in 1 minute. So now my problem becomes simple. In 10 meter, how many ants are there? And we know the length of one ant 1 centimeter. So I divided 10 meter with 1 centimeter. So I got it. Same problem. Only numbers are different. Simple toughy maths.
A little bit change my answer. Multiply 10 raised to 9 in the first. 3 into 10 raised to 8 into 700.
Okay, that will not make the difference, right? Whether you multiply with this with that or that with this, the answer is same, right?
So that's my answer.
Okay. Anyone else has another answer? Okay, so this is my bit of advice to you. Don't do such problems in mind. Okay, draw and do it. Let us make the same drawing. And let us start counting from a specific point. So I'm starting counting from here. Okay, so this wave, in 1 second, I start counting from here. So the wave from this point onwards, in 1 second, the first wave will reach here. Second wave behind that, third wave behind that will reach here. So what is this distance?
3 into 10 raised to 8.
That is what it is speed. Right? In 1 second, this will travel 3 into 10 raised to 8 meter per second. That means if I am starting to measure from here, the first wave in 1 second will travel 3 into 10 raised to 8. Same like and or wave or anything, unless it takes a U-turn or goal checker say ulta and go in other direction, it won't change. So in 1 second, this will reach here. In second, it will reach 1 more second. 3 into 10 raised to 8 meter. Now our problem is straightforward. We want to see in 1 second how many waves passed. Whatever waves passed in 1 second are between this and this point. So our problem became, in this distance, how many waves are there? In this distance, how many waves are there? And you know the length of
12.
one wave.
12.
Yeah? If this is the length, and one wave is 700. So how many waves are there?
Divide.
Yeah, so why, if you were there with me, I would have given you one kick on your head. Because you know
You just count the waves. It's tough.
See, it is so simple. It is so simple, but you are hell bent on not applying what you learned. See, they are trying to do in mind. You do 2 steps in one. This thing. See, it's not lack of knowledge, lack of intelligence. It is clearly the naughtiness. Why? That's why you are making mistakes. It's straightforward. I told you it is the same and problem. It's same thing. Nothing in that problem. Number of waves per second is this divided by 700. You get some value. All of you get this?
Yes, sir.
Yes.
So what is it called? Number of waves per second.
Frequency.
So that is frequency. Superb. Who told that?
The Sriyesh.
Superb. That is what is called frequency. This is how you calculate frequency. In 1 second, how many waves will pass? So what is frequency depending upon? When will frequency be more? When will the frequent number of waves pass?
During noon time.
You look into this and tell me In this diagram, what parameter will decide the number of frequencies more or less?
The number
The
of waves.
distance.
Yeah,
Number of waves.
number of waves. What will decide the number of waves?
The
Yes,
length of
there's
wave.
12 waves, so
Length of wave.
Length of the wave, the wavelength. The first answer of Avinash, you should decide. Avinash should always tell in his answer paper, teacher, I have bit of urgency to go. So first answer of mine, you don't take. My second answer, you should take. Yeah, his second answer will be right. So the wavelength, if it is more, what will happen to frequency?
it'll also be
Will reduce.
it'll be reduced. It'll reduce.
Yeah, you just visualize, you assume you are standing in a toll plaza where toll is collecting. One line is of trucks, another line is of car, next line is of scooters. Assume one truck behind another truck, one another behind, straight it is standing. So if you are in a constant point, you see from here all trucks line, from here car line, from here scooter line. In which line more number of vehicles will be there?
Scooter line.
Scooter.
Why?
Size
Because
of
its length is
Like this short, right? Many people used to make this mistake when they go in tall, they will see the big truck and see, okay, let us go behind, not go behind that. Actually, if you go in the truck line, you can't go in truck line. But if there are more trucks, if it is mixed going, if you go in the line where trucks are there, you will go faster because less number of vehicles are there. The process is less. In scooter line, there are more vehicles. That many tolls has to be collected. Yeah. So the simple principle is, if your length is more, the number of vehicles will be less. Yeah. So if your wavelength is less, that means the number of waves passing in 1 second of frequency is more. But your speed is same. Your speed has nothing to do with this. You understand? So when you tell, like, do you use this word frequency normally?
Yes.
Okay,
Sound.
For what? Okay, for what you use frequency?
a sound measure.
Sound measurement.
Pitch of sound.
You do measure sound on a daily basis?
Pitch of sound.
Pitch of sound. Okay. Do you use in daily basis frequency? Anyone?
It's my password for my phone, so yeah.
Okay.
So for radios,
You see, that is the way you use 94.3 FM, 102.2. What does that mean?
the frequency of
That is
the
the
signal.
frequency in megahertz. How many waves in 1 second is reaching your radio? That you hear on a daily basis, right? The RJ will shout and tell, right? Okay, tan kadakin fun 94.3 means this. Yeah. Okay. Right. So the unit is called hertz, number of this thing per second. You see now, this is the approximate wavelength of different colors.
So hertz is the unit of sound, right?
No, it is the unit of frequency. You use it in sound also. Hertz is the unit called of frequency. How many number in 1 second? That is called hertz.
I see.
Yeah. Do you know your power supply is 50 hertz?
In my home?
Or 60 hertz? You just go and see your any electrical equipment at your home and just see behind you would be written the voltage, the current, and 50 hertz or 60 hertz. You know what does it mean?
It has 60 waves coming through.
Per second. Yes. The electrical supply which is coming to your house is 50 waves in 1 second. In US, mostly it is 60. That's what it means. It's nothing to do with sound alone. But you use mostly for sound. Look at here. You see the colors here? So what will be the order of frequency?
Red means low frequency and purple means really, really high frequency.
Yeah, that is right. You see? So this is the difference between different a light. Actually, this is what is meant by color. You are able to see some color because of this difference in wavelength or frequency. If wavelength is more, frequency is less. Wavelength is less, frequency is more. But speed is constant. Yeah?
Sir, I have a doubt.
Please.
So if the wavelength of red color is less, then will it be more, vibrant than other colors?
Then it won't be red. If the wavelength
So
changes.
like red has a wavelength which is, frequency which is less than other colors. So does that mean it can travel more distance than other colors?
Yeah. Red can travel more distance. You know why we say that now? Because it is long. So obstacles it can overcome and go. So, but
no, so these colors are they just to represent, right? In reality, are they like
this is reality.
Does this mean no? Like if we show rainbow colored lights, will red light have less frequency than purple light, or is this just to represent?
No, this is reality.
Is that why we don't see purple in rainbow, because it doesn't travel long?
No, you see actually what happens is normally the sky is bluish normal time, because this is having a short wavelength, so it can propagate faster actually, so it will propagate more. And this what happens is, if there are large obstacles, large obstacles, this can cover and go. But this is actually shorter, so through inside and all it can go. So that is why you see the sky as bluish normally. But during horizon, just complete this. During early morning and evening, sun is bit far off. You see, sun is bit far off, right, in the horizon.
Now, does the frequency affect visibility? Because the force, which one, the one with high frequency or low frequency will travel further?
Yeah, so it actually what happens is the higher wavelength, more wavelength will travel more distance, because it can cover bumpy stuff, because it is having length and it will cover. What will happen? The shorter wavelength one, it can penetrate through inside these things and go, because it is shorter. But then what will happen is it will propagate first and it will go. It will propagate first and this thing, and then it will go. But if there's slightly larger kind of obstacles, then this can't cross. But red kind of stuffs can cross larger stuffs also. That is why fog and all, you will use yellow light, fog light. It can go for long.
In sound, it's different, right? In sound, the lower frequency means it's really loud, and the
that is a different thing. That is a different thing. Yeah, in sound, yes, it is different, and that is a different thing. This is, we are talking about how it travels. That one is your experience, ear experience, the noise experience. That is two different things. Those two are two different things. But high frequency means that sound will come to you at a very high frequency. After some high frequency, your capacity to hear that will go off. You can't hear. The extremely low frequency, you can't hear, you can't detect. So
in light, the one with higher frequency has more energy to go further.
Exactly. Higher frequency needs more energy. But what will happen is, this can't overtake. If there's a big obstacle, this can't overtake. If there's an obstacle of this size, it can't overtake. But this size obstacle, this will jump and go.
So, but what is the obstacle?
Obstacle can be dust.
Matter.
Atmospheric dust, matter, dust. If it is hitting in your body, your flesh. Yeah. But the bottom line is, this is simple toffee maths. That is what I want to convey. Right? Okay, we stop there. So this is some, if at all you get like nano and all I have used, if you want to get an idea, you can just look. Nano is 10 raised to minus 9, micro is 10 raised to minus 6. These are the words which we use to represent extremely large and extremely small numbers.